Okay, let's get right into it. We're tackling a topic that's honestly a massive part of your GCSE physics exam, the big showdown between series and parallel circuits. You've got to get these two straight, because once you nail down the rules, you can solve pretty much any circuit problem they throw at you.
So you look at these two, and at first glance, they seem kind of similar, right? Both have a battery, both have a couple of components. But here's the thing. That tiny difference in how they're wired, it changes absolutely everything. With a series circuit, you've got one single continuous loop. For parallel, the path splits into different branches. And that one difference, well, that's the key to this whole explainer. So here's our game plan for today. First, we'll get a clear definition for both layouts. Then, we're going to put them head-to-head on the three big things you have to know for your exam: current, potential difference, and resistance. And to wrap it all up, we'll put everything into one ultimate summary. Sound good? Let's go.
Right. First up, one circuit, two ways. Let's make sure we're all on the same page about these fundamental layouts.
Okay, so a series circuit is the simple one. The best way to think about it is like a single-lane country road. The electricity, the current, has only one path to follow. It has to go through every single component, one after the other. And that means if there's a break anywhere in that road, the whole thing just stops. Now, a parallel circuit, this is more like a big motorway with loads of different lanes. The current flows out of the battery, and then it gets to a junction and splits up. Some goes down one branch, some goes down another. The crucial thing to remember is that there's more than one path for the current to take. All right, section 2, this is round 1 of our comparison, the flow of current. Let's dig into how the charge actually moves through these two different setups. So back to our series circuit, that single-lane road. Because there's only one path, the current is exactly the same at every single point. Imagine cars on that road. The number of cars passing you every minute is the same whether you're at the beginning, middle, or end. The current doesn't get used up as it goes along. It's constant. But in a parallel circuit, it's a totally different story. The total current leaves the battery, but then it splits up when it hits those branches. Think of a river splitting into a bunch of smaller streams. The amount of water flowing in each little stream might be different, but if you add them all up, you get the total flow of the main river. It's the exact same idea here. Okay, let's just pause there for a second and lock this in. When we're talking about current in a series circuit, it's the same everywhere. In a parallel circuit, it splits. That's your first massive difference.
Perfect. On to section 3, our next big showdown, potential difference. You probably know it better as voltage. This is all about how the energy from the battery gets handed out in the circuit.
In a series circuit, all the components are in it together. They have to share the energy. So if you've got a 12-volt battery and two identical light bulbs, they'll each get a 6-volt slice of the pie. All the little potential differences across the components have to add up to the total voltage of the battery. Now check this out, because parallel circuits are completely different. This is a super important point. Here, every single branch gets the full whack of potential difference from the battery. So with that same 12-volt battery, every component on every separate branch gets the full 12 volts, no sharing needed. So there's our second major difference. For potential difference, or voltage, in series, it's shared. In parallel, it's the same across each branch. Hey, have you noticed the pattern yet? The rules for current and potential difference are basically flipped for the two types of circuit. That's a brilliant way to remember it for the exam. And that brings us to our final big comparison in section 4, total resistance. This is all about how much the circuit fights back against the flow of current. And, you guessed it, the rules for series and parallel are complete opposites. For a series circuit, calculating the resistance is nice and easy. The total resistance is just the sum of all the individual resistances. You just add them up. So the more resistors you add in series, the higher the total resistance gets, and the harder it is for the current to flow. The formula is literally just R total equals R1 plus R2, and so on. Simple. Now for the one that messes with your head a bit. In a parallel circuit, adding more resistors actually decreases the total resistance. I know, it sounds a bit weird, but think back to our motorway analogy. By adding another branch, you're essentially opening up another lane for the traffic to flow through. More paths make it easier for the overall current to get through, which means the total resistance is lower. So, the bottom line for resistance is this. Adding components in series increases the total resistance. Adding them in parallel decreases it. This is the idea that trips a lot of people up, so really make sure you've got that one down. Okay, we've battled through the 3 key comparisons. Now for the grand finale, Section 5, the ultimate summary. We're going to put everything we've just talked about onto one single powerful revision card. Seriously, this is the slide you want to screenshot. This is the one to burn into your memory for the exam. And here it is, the complete breakdown. Let's run through it one more time. In series, current is the same, potential difference is shared, and total resistance goes up. In parallel, current splits, potential difference is the same, and total resistance goes down. Just look at those patterns. They're basically mirror images of each other. If you know this table, you know this topic. So why does all this matter? Well, because when you sit down for your exam, you're going to get these messy-looking circuit diagrams, and they'll ask you to calculate things. Without a rock-solid grasp of these rules, those questions are basically impossible. But with them, they're just a puzzle that you know how to solve. And to finish off, here's a little something to think about. The lights in your house, all your plug sockets, they're all wired in parallel. Why? Based on everything we've just covered, why is it so important that they aren't wired in series? Think about it. What would happen if one light bulb blew? The answer to that question is right there in the rules we've just learned.